Hello, good evening. Am I audible? If I'm audible, okay. Type, please type there. Let me know if I'm audible or not. Gitsu also came or what? Type in the comment. Okay, Gitsu also there. Okay, let's start. So today, what are we going to study? You go to your page book reflexive. What to say? Wait. Where is that? Okay, let me do one setting. Okay. Okay, special type of relations. So we have learned earlier different types of relation. Okay, again some more types we will learn. Yeah, hey, okay. If I zoom, whether it is visible or not, this is too much. Okay, this much. Is it visible properly? Yes, 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 yes. Okay. Okay, it is visible properly, right? Okay. Yes, I'm audible still. Okay. So, reflexive relation. So, what type of relation is this? Okay. Now, you see here, say A. Like, where is the draw? Pen, pen, pen. So, A, what happened? So, let A be a set and R be a relation on A. Okay. Such that, so R on be a relation, then R is called a reflective relation if AA belongs to R. For all A belongs to A. In other words, R is reflexive if we have, okay, the relation A on A. For example, for all A belongs to A. That means whatever be the elements, it should belong to the relation A, the set A. That means whatever elements we have on with. See here, for example, it is written here. Let A is what? 1, 2, 3, 4. Okay, then the relation C 1, 1. You see, then the relation R equal 1, 1, 1, 4, 2, 2, 2, 3, 3, 3, 4, 2, 4, 4. Okay, on set A is a reflective relation. You see, 2 and 2, 1, 1, 1, 4. This 4 also belongs to A. 3, 3, 3 also belongs to A. 4 and 2. You see, both, okay, both 4 and 2, it belongs to where? A. So when all the elements on the relation, okay, belongs to the set A itself, then such type of relation will be called your reflexive relation. So because you see every element of A is related to itself, A belongs to R. Actually we used to have AB, right? But here the B is also it is different to identity relation. In identity relation, okay, it should have both same number. See, like this one, this will be your identity relation, or this one, or this one. But here in this reflexive relation, we could have this 1, 4, 2, 3, 4, 2. Okay, the element must belong to this set, whatever be the set, okay, we have been given. So such type of relation will be your reflexive relation. See again, this A be a set and R be a relation on A. Okay, you write in your book copy. Okay, then this R is called a relation, reflexive relation, if the condition is given here, AA belongs to R, that means the element AA means what? The elements on this R. Okay, it should belongs. If AA belongs to R, for all A belongs to A. So that small letter A should be the element of this capital A set. So another words are reflexive if we have A RA for all, A related to A for all, A belongs to A, small a belongs to capital A. See example 2. Okay, S equal to A B C D E. This is the set. Now the relation R1 AC AA AE, okay, BB CC EE on S, okay, is not reflexive because D belongs to S. You see, this D it belongs to S है ना, कहाँ पे S पे है ना A B C D E, but D does not belongs to R1. You see in R1, you see in this relation, do we have DD? EE है, CC है, BB है, AE है, but DD नहीं है. So that is why it is not a reflexive relation. Again, example 3. Let us define a relation R on the set of natural numbers n by this one, x related to y. Okay, if x is a divisor of y, natural number hai, okay, this is a set on natural number. So now x is a divisor, this x is a divisor of y. For x, y belongs to n. Chalo, x is a divisor of y. So here x it belongs to R. For x belongs to n, since its natural number is a divisor of itself. Yes or no? 2, say the number 2. 2 can be divided by 2. So say x is 2, right? X is a divisor of y. So y is 4. Okay, no doubt. But 2 itself can be divided by 2 itself. See here, 1 1 2 2 3 3 4 4. This is an identity relation which is reflexive. So same thing here. Okay, and along with that we can also have 2 4. That means the main condition is that this x should belongs to R. X or A, okay, same thing must belongs to R. Then only we can say that it is a reflexive relation. So remark में देखते हैं क्या है. The students should find that identity relation on a non-empty set A is always reflexive relation on A. ये देखो, identity relation, okay, is always a reflexive relation, but all reflexive relation is not identity. So however, a reflexive relation on A is not necessarily the identity relation. Identity relation nahi hai this. So the okay, in example 1 we have got 2 4 something like that, they 4 2 1 4 like this, along with the identity relation. So that is a reflexive relation. But in identity relation, apart from this one, same element, you cannot have the other elements. So the identity relation on the set A is this one, which is also reflexive. Do you understand reflexive relation? In reflexive relation, you can have more than the elements of identity relation. Okay, but the elements of identity relation must be there in reflexive relation. This is a difference between identity relation and reflexive relation. Are you able to process Gitsu, Longminder? If yes, then type reflexive relation. Okay. Then now let's go to another one. Gitsu, is he present or not? I think he became offline again. He will watch later, I think. Now will come symmetric relation. What is symmetric? तो सिमेट्रिक तो क्या है? देखने में सेम सेम होना चाहिए ना? सेम सेम या फिर क्या है? लेफ्ट राइट इट शुड बी इक्वल. दे समथिंग लाइक दैट. चलो क्या क्या देखते हैं. What is a symmetric relation? So let R be a relation on the set A. Chalo. Then R is said to be symmetric. Then R is said to be symmetric relation if this is a condition now. AB belongs to R. This implies BA. See? ठीक उसका उल्टा BA also belongs to R. If it is 1, 2, then you should have 2, 1. It should belongs to R. Chalo. In a symmetric relation, B related to A whenever we have A related to B. So we will have this 2. Okay. That means a relation and then its inverse, it must present together. For AB belongs to A. This is our symmetry relation. So see the example. Let A is 1, 2, 3, 4. 1, 2, 3, 4. Now what is the relation R on A is? See, 1, 1. Okay, we have 1, 1, 1, 3. देखो 2, 2, 1, 4. चलो. Now इसका उल्टा है कि नहीं? 1, 3 का क्या है? 3, 1. Yes. 1, 4 का क्या है? 4, 1. It is present. Then we have 4, 4. 4, 4 का तो 4, 4 ही होगा. Again, now if we add here 1, 2, okay, then we must have here 2, 1. Then only it will be called a relation, a symmetric relation. ठीक है? 1, 2. Oh, it is 2. So if we are supposed to add 1 to here, okay, 1 comma 2, then we must also add 2 comma 1. But if we are writing this all elements but not writing 2 1, then it will not be called your symmetric relation. Okay, so here R is a symmetric relation on A, but it is not reflexive. Why? क्या एलिमेंट ज़्यादा हो गया? Okay, that is the reason. You think and then you tell me. Okay. ये इस relation में something is missing. Who is missing? 3 3 is missing. Right? So that is why it is not your reflexive relation. A, okay, A must be there, or XX. Again, for example 2. Let's go to example 2. Okay, let A be the set of all straight lines on a plane, then a relation R on L defines as L1 is perpendicular to L2. This is L1, this is L2. So these are perpendicular. For L1, L2 belongs to L. Set of all this one line. Okay, L. Straight line is a symmetric relation on L. देखो once once we say that this is perpendicular to this, it also means that this is perpendicular to this. Yes or no? ये it can be written like this. तो इसमें और यहाँ पे क्या हो गया है? इस लाइन को ये 90 डिग्री बना रहा है. Yes. So they are vice versa. That is why it is your symmetric relation. If one is perpendicular to the other, then the other is also perpendicular to the first one. ठीक है? Okay, now will come your transitive relation. ये क्या है? What is your transitive relation? Let R be a relation on A. उसके बाद क्या है? What is the relation? R is said to be transitive. Okay. If AB belongs to R and BC belongs to R. This implies AC will also belongs to R. AC belongs to R. Okay. A and B, then B and C. Then this will say that AC also belongs to R. For example, for all, not for example, for all A, B, C, all the three elements A, B, C must belongs to the set A. So therefore, in a transitive relation, R on A, if A related to B and B related to C, then A related to C. So this is your transitive relation. For all, okay, A, B, C belongs to A. Okay, for the set of all natural numbers n, let us define a relation R as x is less than y. See this example? X is less than y for x, y belongs to n. Then the relation R is a transitive relation on n. Why? Since A is less than B and B is less than C. So obviously A will be less than C. Yes? So for A, B, C belongs to n. Again, example 2. Set of all straight lines on a plane, then the relation R defined as is parallel to, okay, one is parallel to the other, okay, on the set of lines L is a transitive relation. You see, this is class 9, I think. You remember your class 9 maths. If one line is parallel to the other and the other is parallel to the third one, then the first and the third one are parallel. You see, L1 is parallel to L2, L2 is parallel to L3, so L1 will be parallel to L3. So such types of relation is your transitive relation. Okay, now will come your anti-symmetric transition relation. Anti-symmetric मतलब उल्टा ना, symmetric का उल्टा, anti-symmetric. Okay, if so, let R be a relation on set A. Let R be a relation on set A. Okay, then R is said to be anti-symmetric relation if AB belongs to R. Okay, the element AB belongs to R and BA belongs to R, and then this AB is equal. So when AB belongs to R and BA belongs to R, but A and B are equal. So in other words, okay, A not equal to B. If A is not equal to B, then possibly A is related to B. Okay, अगर A और B equal नहीं है, तो possibly A is related to B or possibly B is related to A, but never both. So this is your anti-symmetry. So with the example, okay, we will be more clearer about it. So okay, let's go. Where is the, okay, see this example. Let इसमें क्या है, सिमेट्रिक वाला कंडीशन होना चाहिए, ओके, लेकिन the elements should be equal. So let R be a relation on the set of natural numbers and defined by this one, x related to B, okay, such that x divides y for all xy belongs to n. So x, okay, or y, x will divide y. So this relative R is anti-symmetric on n because for any two natural number xy, okay, if x divides y and y divides x, then x equal to y है कि नहीं? अगर x y को डिवाइड करेगा and y x को डिवाइड कर सकेगा, then they will be equal. लेकिन in other words, x related to y and y related to x implies x equal to y. We cannot have other numbers. But okay, अगर ये दोनों unequal है, x और y is not equal, then we cannot have this both. X divides y and y divides x. It is a very, you can have a very simple example. say the number 2 and then 4, right? X divides y, so 4 is easily divisible by 2, लेकिन क्या 4 2 से क्या 2 4 से can you divide 2 by 4? Nah. Yes or no? 4 can be divided by 2, but 2 cannot be divided by 4. Right? Completely divisible नहीं हो सकता. Half आएगा answer. Yes? You'll get a fraction. Completely divisible. Say 2 and then 3. Okay? You cannot, because they are not divisible. But if they are equal, okay, 2 and 2, so 2 can be divided by 2, 2 can be divided by 2. 3 3, 3 can be divided by 3, 3 can be divided by 3. Why? Because here x and y are equal. So such type of relation is your anti-symmetric. Okay. So note, it is given. It is to be noted that if we define the above relation in the set of integers z, then the relation is not anti-symmetric. Yeah, z hoy, then it will not be called anti-symmetric, because a is not equal to 0. Because if a not equal to 0 is an integer, then a divides minus a and minus a divides a. But a is not equal to minus a. तो नेचुरल नंबर में वैलिड है, बट इंटीजर में इट इज नॉट वैलिड, क्योंकि see a can be divided by minus a. They are two different numbers. Again, see, minus a and a, okay, it can be divided, right? Lekin a or minus a is not equal, so that is why it is not anti-symmetric. ठीक बा. Again, the relation greater than equal, okay, greater than or equal to defined the set of real numbers is anti-symmetric. If a is greater than equal to b and b is greater than equal to a, then a is equal to b for all reals a and b. हाँ है ना? Chini ne lang nam de da je. Okay, so now equivalence relation. क्या है equivalence relation? So a relation R on a set A is said to be equivalence relation on A if equivalence है ना, equal होना है, equal equal भी नहीं, चलो. A relation R on a set A is said to be an equivalence relation on A if, number 1, R is reflexive, that is A belongs to R for all A. So जितना भी A है, okay, it must belongs to A. Then R is symmetric, AB belongs to R. and BA belongs to R, है ना? For all AB belongs to A, R is transitive. Okay, these three conditions must satisfy. Then only we can say that they are equivalent relations. AB belongs to R, BC belongs to R. This is transitive, right? So AC will be belongs to R, such that AC belongs to R. So for all ABC belongs to. So for it to become a relation to be equivalence relation, it must satisfy the three conditions. One is that it should be reflexive, another it should be symmetric, and third it should be transitive. So example, let's see the example. Let T be the set of triangles on Euclidean plane. Euclidean means two-dimensional plane. Okay. Triangle hai. T is a set of triangles where R be a relation on T defined as A related to Y, A related to Y, X related to Y, okay, if and only if X is congruent to Y. X is congruent to Y for XY belongs to T. X is congruent to Y, so for XY belongs to T. So what we can observe here, क्या है, X Y के साथ congruent होना है. The relation is such that it should congruent to the another triangle. X and Y are triangles. Okay. So now see, X related to X and X itself will be congruent to itself, since every triangle is congruent to itself. So thus R is reflexive. Chalo, reflexive condition to fulfill हुआ. Next, X related to Y and Y related to X. हाँ, ये भी fulfill होगा. If X is congruent to Y, then Y, the triangle Y will also be congruent to X. Yes. So the triangle X is congruent to the triangle Y. Then Y is congruent to X. Yes, so we will have R is, we can say that R is symmetric. Now, चलो अभी दो triangle हो रहा है. Let's introduce another triangle, one more triangle, X, Y, and Z. Okay, Z be the another triangle. So X is related to Y. That means X is congruent to Y. And Y related to Z means Y is congruent to Z. So by default, okay, X will be congruent to Z. Yes, since all of these are congruent. So we can say that R is related to Z. So since if triangle X is congruent to Y, triangle Y is congruent to Z, then X is congruent to Z. So for X, Y belongs to T. So thus R is transitive. So this set of triangles is in which one is congruent to the other is an equivalence relation. तो congruent मतलब क्या, सब triangles equal है. So we can say it is seen that R is reflexive, symmetric, and transitive. So therefore R is an equivalence relation. Clear? Again, for the similar one also, it is equivalent relation. If one is similar to the other, so the other will also be similar to the other. X and X, okay, same. X and X is similar, right? So X is similar to Y. Then when we introduce another similar triangle Z, in which Y is similar to Z, then since x is similar to y and y is similar to z, okay, so x and z will also be similar, so that is why it is also transitive. So it fulfills the three conditions: the condition that it is reflexive, it is symmetric, it is transitive. If x is similar to y, then y is also similar to x, which is your symmetric relation. Yes? Okay. Then what do we have next? So, समझ में आया? Do you understand up to this much? You type in the comment, okay? Then we will go to the next section, graphs of relation. So what is this graphs of relation? Gitsu, what to prove a relation is equivalent? Okay, can you type again? Ha ha ha. Yes, yes. Then only we can say that it is equivalent relation. Yes, yes. All these three conditions must be fulfilled. Otherwise, we cannot say that they are equivalent relation. Yes, all of it. Okay, then let's come to graph of relation. So earlier we have discussed this one, pictorial representation of relation in 6 different ways, right? How to represent relation, arrow diagram and all, matrix, they. So in this section we will show some graphs of relation through examples. तो क्या है इसका examples? Okay, let's see. So you see here, when we plot the ordered pairs, okay, when we plot the ordered pairs, है ना, x y, okay, ordered pairs or a b, okay, belonging to a relation on the two-dimensional Cartesian plane, then those points represent the locus of the relation. Locus means the point. Okay, locus of the relation under consideration. So the geometrical representation of the locus by discrete points, okay, or by a curve is the graph of the relation. Discrete points, discrete means not continuous. Okay, khatam ho jatna wala, that is called your discrete, or a curve. Okay, this is here, this will be the graph of the relation R. So these graphs, okay, it will categorize into two groups. One is set of discrete points, and the another is continuous curve or a region. So we will have two type of graphs. So first one is discrete points. You see, these are the discrete points. See, khatam ho jata hai, right? It is not continuous. So kya kya diya gaya hai? Let's see. So let A 2 3 4 5. Okay. B 3 4 5 6 7. Okay, ये दोनों two sets है. Then we need to grow the relation from A to B. Okay, defined as A related to Y, X related to Y. So X will be the element on A, Y will be the element on B. If X divides Y, for X belongs to A and Y belongs to B. So X should divides Y. So 2 4 2 4. और यहाँ पे 4, right? 2 4 2 6. It 2 can divide 6. 2 2 तो नहीं है. Then we have 3 3. Yes, 3 and 6. 4 4 5 5. So the element in A should divide the element in B. So we have got this relation 2 4 2 6 2 4 2 6 3 3 3 6 4 4 5 5. So now when we plot, okay, all these things 1 2 3, okay, 1 2 3 4 5 6 3 4 5 6 7 8, then what do we get? 2 and 4, this is our first ordered pair. 2 and 6, 3 3 3 6 4 4 5 5. Okay, then we don't have 6. So this is the graph of discrete points. ठीक है. Then again, let's go to the next page. This is just nothing but just like plotting graphs. Okay, you have got your x and y coordinate, right? So the ordered pair is x as x and y coordinates. See, x, this is y. So we have got the relation x y such that y is equal to 3x. 3 guna lagan. So x y belongs to n. So some of the elements here, R is an infinite set. Okay. So 1 3 2 6 3 9 4 12, 3 गुना, right? 1 का 3 गुना किया है 3, 2 का 3 गुना किया है 6, 2 3 6, 3 3 9, 4 3 12, 5 3 15, 6 3 18. It will go on like this. So now when you plot the graph like this, okay, on the xy plane, then you will get to see like this: 1 3 2 6 3 9. So this is the discrete points. क्योंकि ये you see here, since R contains infinite number of points, that is ordered pairs, okay, so it is not possible to point all the points in the plane. So it will go on like this. Then now come your set of continuous points. तो ये रहा तुम्हारा set of continuous points. If you join them, okay, this becomes your curve, a line, okay, which is your continuous. If you join those points, then it will become continuous. So we have given a relation R1, see, -2, -6, -1, -3, 0, 0, 1, 3, 2, 6. So here the domain of the relations is that is the set of the real numbers R, okay, is itself. And so the graph is a continuous curve. Here it is a straight line, which is shown in this figure. You see, this is your continuous figure. ठीक है. Clearly आ रहा है ना picture? Okay. Same, see here. This becomes a region now. Okay, if you shaded them, it becomes a region. You see, draw the graph of the relation R2 where R2 equal xy such that draw the graph of the relation R2, okay, where R2 equal xy such that xy related belongs to R, and then y is less than x plus 1, less than or equal to x plus 1. तो 1 plus x को अगर 1 लिया तो 1 plus 1 क्या होगा 2. So it can be either 2 or -1, or it can be 0, less than or equal to this one, right? So here the domain of the relation R2 is a set of real numbers. So first we draw the straight line, okay, represented by this y equal to x plus 1, less than को छोड़ के, okay, y equal है on the rectangular Cartesian plane. Then the graph of the relation is the line y equal to x plus 1. So x and y ka point, okay, using this equation we can find out this point. If x is 1, then y will be 2. You see, x is 1, y is 2. If x is 0, then y is 1. So ये रहा. Clear? Similarly, okay, we will get this type of points. Now, now ये हो गया तो हमारा equal. अभी less than भी होगा, and we don't know how much it is less than. Okay, so this becomes your shaded region. The less thans are your shaded region. So in this region, okay, any point can fall in this region, okay, for the x less than y less than x plus 1. So this is the region. So it can be a curve or it can be a region. That is your continuous. Okay. So examples are given here. You try to do by yourself. ठीक है. How to show this one? Transitivity, symmetric, reflexivity. Okay. ये सब दिखाना होगा if you have to show them equivalent. So you are asking me, right? So example 6 is the answer to your question. So if R is an equivalent relation on set A, then R inverse is also an equivalent relation on A. तो इसको R inverse को प्रूफ करने के लिए हमको क्या दिखाना होगा? पहले R inverse is reflexive, R inverse is symmetric, R inverse is transitive. ये दिखाना होगा. Question 1, question 2, okay. Question 3, question 4, question 5. नहीं है क्या? question 5. Up to question 5, it becomes your homework. That means you try by yourself first. ठीक है? Seeing the examples and all, you try to do first. Then if you cannot, then you text me on the group. You inform me. Then in the next class, we will try to do. ठीक है? So demonstrate by examples that identity relations on a non-empty set is always reflexive relation. However, a reflexive relation is not necessarily an identity relation. Okay. So let R be a relation defined by a set of natural relations so that R is not an equivalent relation. Okay. 6, 7, 8. How many questions we have? 13 questions are there. Okay, let R be a relation defined as R equal xy such that x minus y is divisible. Okay, so then they are equivalent relation. Let R and S be two relations. Okay, true or false. TK, these are the given condition. Then give an example to show. Okay. So from 7, 6D. I will show you how to do. I will show you. So we will do the questions tomorrow. Okay. So today up to tomorrow, you try to do up to 5. Okay. You write in the comment. ठीक है कि नहीं ठीक है. ठीक बा या ना ठीक बा. First, you will note down the different examples. Okay. You note it down on the examples in your copy. Then, okay, once you able to comprehend the examples, then it will be easier, okay, to do the exercise. And then tomorrow we will complete this exercise, this chapter. Okay. Then after that we will go to the next chapter. Complex number, arithmetic of integers. Okay, slowly and steadily. Then today we will sum up to here. You try by yourself. Okay, then. And if you have any doubts, then you type in the group. Okay. In tomorrow we will clear all the confusions. Clear? Then I'm leaving you all for the evening. Bye bye.